So let's take a look at another system of three equations. This time it's going to be what we call a dependent. You'll see why in just a minute that we call it dependent. And now let's just pretend that I have no idea that the system is actually dependent. So I'm just going to go ahead and grab two equations. I'm going to multiply this one by -5, right? I'm just trying to get a letter to go away. So I'm going to focus on this first, the x, and so I have 5x plus 5y minus 5z. You're already noticing, I'm sure, something, and I'm just going to pretend like that I'm just a little bit oblivious to what is happening. Okay, and then that's going to be plus 5z, and that's equal to -15. And when I look at this and I go about adding my columns, I was just trying to get the x alone, the x to be eliminated, and look what's happened. I get that everything gets eliminated. Well, and then if I take a look at the other two here, if I multiply this row here by a -2, right, we'll see that the same thing is going to happen. We're going to get 0 equals 0 when we combine those last two things. So here's what we know. We know that these planes are all the same. It's the same plane. Okay, and we can tell that because these can all be, this one right here can be made into this one, and this one can be made into this one, and so we get the same plane. So what we're gonna, when we see that, the way we write that as an answer, let me just show you this. The way we write it is this. We say, here's the solution set. It is any x, y, and z such that this is the relationship between the x, the y, and the z. As long as that's the relationship, right, then we have that's the solution. As long as that's the relationship between x, y, and z, then that x, y, and z will actually work for any of these three equations. So, pretty simple, right? That's a quick video. Thanks for watching.